Let's remember, if we multiply radical x times radical x, initially we would get radical x squared. Remember, you add your exponents when you're multiplying those. So then the square root of x squared would simply just give us x. Because remember, you divide your exponent by whatever your index is. If no number is written, that means there's a little 2 out there. So 2 divided by 2 gives us x to the first. So now for our second example, if we have cube root of x times cube root of x times cube root of x, that means I have 3 of them. So initially when I multiply, I would get the cube root of x cubed, because, again, 3 x's you're multiplying, so 1 plus 1 plus 1 is 3. Divide those exponents, we would get x to the first. 3 divided by 3 gives us 1. So then the little short rule for that, I tried mentioning it before. We're going to be using it a lot today. A square root and a square simply cancel each other out, and it's just whatever's underneath the radical sign. So the square root of x squared, that square root and square cancel each other out, it's just x. My example next to it, the square root and the squared cancel each other out, so that would simply be 5x. Same thing happens with our cube roots. They cancel each other out, so cube root and cubed, inverse operations cancel each other out, that'd be x. Our other example there, that would simply just be x plus 1. So those are inverses, just like adding and subtracting are inverses, multiplying and dividing are inverses, so they cancel each other out. So squaring a number is the inverse of taking the square root. Cubing a number is the inverse of taking the cube root. So we're going to be using that rule as we are solving our radical equations. So when you're solving your radical equations, you got to follow these steps here. You first want to isolate the radical, so make sure you've got it entirely by itself. And then you raise both sides of the equation up to the power equal to the index, simplify and solve, and then check your answers. With your radical equations, I'm going to sit here and say 95% of the time, an answer rejects. So you always got to check to see if it rejects or not. It's important that you check with your radical equations here. So let's take a look at example number 1. Here's my radical sign. My first step is I need to isolate my radical sign. It is not isolated yet. It's got this 2 in front of it, and it's got that plus 8 after it, so I need to make those things get away from my radical. So first I will subtract 8. So I then have 2 times my radical equals -4. Again, radical is not completely by itself yet. I got to divide by 2. So I have the square root of 2x minus 6 equals -2. Now our radical is isolated. All you have on that left side is your radical sign. Everything else has been moved over to the right side of my equal sign. So once that happens, radicals by itself, we're going to square both sides of our equal sign. Because again, as we were saying above, square root and a square cancel each other out, so now my radical is gone. I simply have 2x minus 6 over there on the left. Over on the right side, -2 squared would give us a +4, because it's -2 times -2 makes it positive. So now we just have a simple equation to solve. So we'll add our 6 over. So I get 2x equals 10. Divide by 2. And I get x equals 5. So then, again, as I said, you got to check. Because a lot of times with these radical signs, our answers reject. So checking, plugging 5 in for our x. So 2 times the square root of 2 times 5 minus 6 plus an 8. We're going to see if that gives us 4. So 2 times 5 gives us a 10. Minus 6 gives us what? 4. So what's our square root of 4? So this is 2 times 2 plus 8. I'm already telling this isn't going to work. 2 times 2 is 4 plus 8. Does 12 equal 4? No. So this gets rejected. And this actually has no solution. Our answer is what we call extraneous. It doesn't actually work. All right, number 2, let's take a look at that one. So again, first step, we have to get the radical completely by itself. It is not yet. I got to get rid of that 5. How are we going to get rid of that 5? Divide. So now the radical's by itself. This one is a cube root. Last one was a square root. This one is a cube root. So that means I'm going to raise both sides to the 3rd power. Whatever root it is, that is what the exponent's going to be. So left side of our equal sign, we now have 4x plus 3. We've knocked out that radical. Right side, what is 3 to the 3rd power? 27. And then we'll just finish solving for x. Subtract our 3. I get 4x equals 24. Divide by 4, what does x equal? 6. So then again, we want to check. So plugging in our 6 that we got for x. Four times 6 plus 3, what does that give us under our radical? 27. Cube root of 27 would be 3. Because 3 times itself 3 times is 27. So then 5 times 3 gives us 15. So that one checks out. So x equals 6 is our answer there. Let's try a few more. So again, first step, got to get that radical by itself. So that means I need to move this x over. So I add my x over, I get the square root of x squared minus 21 equals x minus 3. So what power are we going to raise both sides to? The second, it's a square root, so to undo a square root, we've got to square it. So over there on the left side, we got x squared minus 21. On the right side, x minus 3 squared. Write it twice and multiply, because if you guys don't write it twice, you will keep making the same mistake and not multiplying it correctly. So x minus 3 squared is x minus 3 times x minus 3. That would give me x squared minus 3x minus 3x plus 9. We got to distribute that thing out. So then the right side, combining my x's, I get x squared minus 6x plus 9 Left side I still have x squared minus 21. So then I'm going to start trying to get my terms together. I'm going to try to bring my x squared over with this x squared. And actually what happens is it cancels on both sides, which sometimes happens. So we have that negative 21 equals negative 6x plus 9. So then I'll bring my 9 over to my 21. Divide by negative 6. And we get x equals 5. So then again, we just have to check our 5, make sure it works. So 5 squared minus 21 minus 5, we're going to see if that gives us a negative 3. So what is 5 squared? 25 minus 21 would give us a 4 under that radical sign. So then the square root of 4 is a 2. Subtract 5 from it, and we do get negative 3 equals negative 3, so it checks out. So x equals 5 we get to keep. Four is a little bit different because we have two radical signs, but are they both by themselves? Yeah, they're both isolated already, so we're good. Radicals are isolated. So we are going to square both sides. And all that does is it knocks out our radicals. So then we just have 5x plus 1 equals 4x plus 3. So then I'll get my x's together. I'll subtract my 4x over. So x plus 1 equals 3. Subtract my 1. So I get x equals 2. So then I'll do my check. So 5 times 2 plus 1, we're going to see if that equals the square root of 4 times 2 plus 3. So 5 times 2 gives us 10, plus 1 gives us 11. So I have radical 11 over there on the left side. 4 times 2 plus 3 equals radical 11. So that checks. All right, 2 more. So number 5, again, we have 2 radicals, 1 on each side. And the one over on the left side, it's 3 radical x. So that one's not completely isolated, but don't write this down yet. If I divide by 3 to make it isolated, do I really make my problem any easier? No, because now I'm just going to have that fraction over there on the right side. So we're just going to leave it as it is, and we're going to follow our same rules. This side is completely isolated, so at least we have one of them that's completely isolated. So we can go ahead and continue with our next step. These ones are square roots, so we'll end up squaring both sides. This 3 also gets squared out here, so 3 squared gives us 9. Radical x squared gives us just x. Over on the right side, our radical goes away, so we have our 5x plus 32. So then I'll subtract my 5x over. So we got 4x equals 32. Divide by 4, what does x equal? 8. Then we'll do our check. 3 radical 8. We're going to see if that equals square root of 5 times 8 plus 32. So what is 5 times 8? Plus 32 will give us 72. So let's try to simplify our 72. What's our largest perfect that goes into 72? Not 9. There's a bigger one. 36. So that simplifies into 6 radical 2. Over on the other side, for our 8, we'll use 4 and 2. What's the square root of 4? Times the 3, though, also gives us 6 radical 2. So that checks out. 6 radical 2 equals 6 radical 2. So then our last one in our notes, number 5. Again, it's kind of like the last one. The radical over there on the right side has that 2 in front of it, but if we divide it, we're just going to get a fraction. It's going to make our life a lot worse. The radical on the left is completely isolated. So we'll just raise them to the cubed power, or the third power there, because they're cube roots this time. So our radical on the left is gone. It's just x plus 6. On the right side, 2 cubed is 8. Remember, you still have to cube that number out in front, so that's 8. And then it's going to be times everything under the radical, which is why I put those parentheses there, because you got to make sure it gets multiplied by the x and the 1. And we'll have to distribute that 8. So we get x plus 6 equals 8x minus 8. And then we'll finish solving for x. So I get my x's together by subtracting my 1x over to my 8x. And then I'll add my 8. Divide by 7. What do we get for x? Then we got to do our check. So plugging in 2 for both of our x's that we had in the original problem. Left side 2 plus 6 gives us the cube root of 8, which is a 2. Right side 2 minus 1 gives us the cube root of 1, which is 1. So 2 times 1 gives us 2. So it checks out. That one works. Sometimes you'll see some problems that lead to quadratics that you have to factor, and one of them almost always cancel or rejects also.